Welcome to The Explainer. If you're the kind of person who absolutely loves knowing how things work under the hood, well, you're in the exact right place today. We're going to decode a piece of technology that literally dictates the pace of our modern lives. But for a lot of people, it still remains a bit of a mystery. So let's dive into the different types of RAM, and we'll break them down using some real-world examples so we can actually picture what is happening inside our machines.
We've all been there, right? You're right in the middle of something totally crucial. Typing up an important document, editing a massive video, or maybe you're in the final circle of a really intense game. And then, suddenly, just out of nowhere, everything stutters. The screen freezes, your cursor turns into that dreaded spinning wheel, and your heart just drops. Why does your device suddenly lag like that? It's incredibly frustrating. Now, most people immediately blame the processor, right? They think the brain of the computer just isn't fast enough to handle it. But actually, more often than not, the processor is just sitting there waiting. It's waiting for data. What you're experiencing in that agonizing moment of lag is a bottleneck in your memory system, specifically your RAM. You see, RAM is this invisible engine responsible for your device's real-time performance. And today, we're going to pop the hood, open up that engine, and see exactly how its different parts work together to keep you moving at top speed.
All right, let's jump right into Section 1, the Invisible Performance Engine.
Okay, let's break this down. RAM stands for Random Access Memory. Think of RAM as this incredibly fast, highly active bridge between your long-term storage and your processor. When you open an application, your device pulls data and loads it straight into the RAM for instant access. Why? Because the processor needs to be able to get to it immediately. Your operating system, the 15 browser tabs you have open right now, the document you're typing in, they are all living in the RAM right at this very second. It's the hardware where your current, active data is kept for lightning-quick access. Let's put it this way. If your computer were a kitchen, your SSD or hard drive is the pantry way down the hall. But the RAM is the countertop right in front of the chef. It's where all the active chopping, mixing, and cooking actually happens. But as we're about to see, not all countertop space is created equal.
That perfectly tees up our first specific category of memory. Section 2, Static RAM, Immediate Access.
Now, to really grasp how this works, we're going to use a workspace analogy. Static RAM, or SRAM, is your immediate desk space. Imagine you're sitting at a physical desk, grinding away on a super complex project. SRAM is the area directly under your hands. It's the sticky notes right on your monitor, the single pan currently in your fingers, the one document you are actively reading at this exact millisecond. Because it is right there, your access time to these items is essentially zero. You don't have to reach, you don't have to search for anything, it is immediate. In the computing world, SRAM is used primarily for the CPU cache. It's built directly into or right next to the processor itself, and because of that, it is blazing, incredibly, mind-bogglingly fast. But just like the space immediately under your hands on a physical desk, the capacity is really small. Plus, it's incredibly expensive and complex to manufacture, so you only get a tiny amount of it. But for the data your processor needs right this very second, SRAM is the undisputed king of speed. Now, let's pivot to the other side of the equation. Section 3, Dynamic RAM, Heavy Lifting.
So if SRAM is the immediate desk space right under your fingertips, Dynamic RAM, or DRAM, is the nearby filing cabinet. Continuing with our workspace analogy here, you obviously can't keep every single file, folder, and reference book for your entire project right in the center of your desk. There just isn't room. Instead, you have this high-capacity filing cabinet sitting right next to your chair. When you need a new document, you just swivel your chair, open the drawer, pull the file, and bring it over to your desk. That is DRAM. It holds a vastly larger amount of data than SRAM. When you're looking at computer specs at the store and it says a laptop has 16 gigabytes of RAM or 32 gigabytes of RAM, they're talking about DRAM. It does the absolute heavy lifting of holding all your open applications and background processes. Now, it takes a tiny fraction of a second longer to access than SRAM, just like turning your chair takes a second, but it gives you the massive capacity you need to multitask without everything crashing.
Now let's put them head to head, SRAM versus DRAM. And the thing to remember here is that it's not a battle where one is inherently better than the other, it's really a partnership of compromise. SRAM gives you that blistering, uncompromised speed, but at a really high manufacturing cost, which strictly limits its capacity. DRAM, on the other hand, gives you high capacity and lower manufacturing costs, but you sacrifice that absolute peak speed. Think of SRAM as a two-seater sports car, right? It's incredibly fast, but you're definitely not using it to help your friend move apartments. DRAM is the delivery van. It's a bit slower getting off the line, but it can carry an entire apartment's worth of furniture in one go. A well-designed computing system relies heavily on both of these working together seamlessly.
And this visual brilliantly illustrates exactly that balance. You can see the direct trade-offs across these RAM types at a single glance. Look at how, as speed goes up, cost shoots right up and capacity goes way down. This is the fundamental balancing act that hardware engineers are dealing with every single day. They have to decide exactly how much expensive SRAM cache to put on the processor to keep it happily fed with data, and exactly how much affordable DRAM to put on the motherboard to ensure you, the user, can actually have 50 browser tabs open without the whole system going up in smoke. Your device's smooth performance is a direct result of this carefully calculated equilibrium.
So, how does this actually play out when you're just sitting there using your devices? Let's check out Section 4, Real-Time Uses in Action. Let's see how this all builds into your actual day-to-day user experience. Take gaming, for example. Your DRAM acts as this massive staging area for the entire map and the high-res character models, while your SRAM is calculating the real-time physics and your lightning-fast controller inputs millisecond by millisecond. In video editing, the DRAM holds those massive, chunky 4K files for quick scrubbing on your timeline, while the SRAM actively crunches all those complex color grading effects. Even background app refreshing on your smartphone relies on this. It uses DRAM to hold your apps in a sort of suspended animation, ready to snap back instantly the second you tap them without needing to reload the whole app from scratch. Finally, let's bring this all back home. Section 5, What this means for you.
So the absolutely crucial point here is this. Understanding the invisible engine of RAM empowers you. Next time you buy a laptop, a phone, or a tablet, you're not just going to blindly look at the processor brand anymore. You'll understand that if you're a heavy multitasker, or a gamer, or a video creator, skimping on DRAM capacity means you are literally forcing your fast processor to wait on that slow pantry down the hall, rather than having everything ready to go in the nearby filing cabinet. You now know exactly why things lag, and more importantly, exactly what hardware prevents it. So I want to leave you with this provocative thought to ponder as we wrap up today's explainer. Look at the machine you are using right now. Think about the lag you might have experienced recently. Is your processor actually too slow, or is your current memory setup actually holding you back? Thank you so much for exploring this with me today. Keep learning, keep asking questions, and I'll catch you in the next explainer.